Welcome to this tutorial on using Elasticsearch with Java. In today's session, we'll cover everything from setting up Elasticsearch to integrating it with Java applications and executing various operations like indexing, searching, and aggregating data. First, let's talk about what Elasticsearch is and why it might be beneficial for your applications. Elasticsearch is a powerful search and analytics engine built on top of Apache Lucene. It's commonly used for full-text search, log and event data analysis, and real-time data indexing. To follow this tutorial, make sure you have JDK 8 or above installed on your system, along with Maven for dependency management. You can download Elasticsearch from its official website and run it locally. Now, let's set up a Maven project for our Java application. Open your command line and create a new directory for your project. Run the following commands to initialize the project. Next, navigate to the newly created project directory with the command. Now, we need to add the Elasticsearch Java client dependency to our pom.xml. Open the file and include the following dependency inside the Dependencies section. Also, if your version of Elasticsearch is compatible with the latest client, ensure to update the version accordingly. After modifying the pom.xml, save it to fetch the dependencies. Next, let's write a simple Java application that connects to Elasticsearch. Create a new Java class Elasticsearch example in src/main/java/com/example/Elasticsearch. In the connect method, we initialize the REST high-level client that provides us the means to interact with our Elasticsearch instance. Ensure that Elasticsearch is running on your local machine and listening on port 9200. Now, let's implement the main method to test our connection. Update your class as follows. Run the application using Maven with mv-in-exec, java, dexec.main class equals com.example.elasticsearch example. You should see the connection message in your terminal. Next, let's explore how to create an index in Elasticsearch. An index in Elasticsearch is like a database in a relational database system. To create an index, we will add a method named createIndex in our Elasticsearch example class. Now, let's modify the main method to call this new method to create an index called test_index. You can run the application again, and you should see a message confirming that the index has been created. Now that we have created an index, let's move on to indexing documents. We can index documents in Elasticsearch using the indexRequest class. Add the following method to index a document in our Elasticsearch example class. Next, let's add some sample document data to our application. In the main method, we will create a JSON string representing a sample document and then index it using the indexDocument method. After running the application again, you will see a message indicating that the document has been indexed. Let's verify that our document was indexed properly by performing a search. To search for documents in Elasticsearch, we'll use the searchRequest class. Add a method called searchDocuments in our class as follows. Now we can call this method in the main method after indexing the document to see the search results. Run the application, and it should now display the total hits obtained from the search query, indicating that our indexed documents are retrievable. Next, we will explore how to use aggregations to get statistics from our data. Add the following method in the Elasticsearch example class to perform an aggregation. Call this new method in the main method after searching documents to get the aggregation result. When you run the application now, you should see the aggregation result for the user field in the output. This is an essential aspect of using Elasticsearch for analytics and business intelligence. Finally, let's discuss error handling. When dealing with external systems like Elasticsearch, it's crucial to implement proper error handling. You can use try-catch blocks around your Elasticsearch operations to handle potential I/O exceptions. This will ensure that your application can gracefully handle errors and allow you to debug issues as they arise. In production-ready applications, you may want to implement logging frameworks for better error tracking. To summarize what we learned today, we covered setting up an Elasticsearch client with Java, creating an index, indexing documents, searching, aggregations, and handling exceptions. This is a powerful combination that you can utilize in various use cases. Thank you for joining this tutorial. Don't forget to subscribe for more programming tutorials. If you have any questions or topics you would like me to cover in the future, feel free to leave a comment down below. Happy coding!